ROS aims to be the Linux of robotics. We aim for ROS to fill a similar role in the robotics industry that Linux fills today for internet startup companies. An open and freely available platform for innovation. ROS is open source software with a commercial-friendly license. That means you can change it in any way you want, and you can freely commercialize on ROS. What this flexibility has already enabled is a fast-growing community of ROS developers, and a community of companies and universities that develop and host ROS code. Today, there are over a dozen companies and universities that are hosting their own ROS repositories. These are code bases developed at these institutions that are free to download and run on ROS. This community has taken ROS well beyond the PR2 robot that we develop on at Willow Garage. Here is a sampling of these other robots on which members of the ROS community have implemented ROS support. Robots ranging from low-cost teaching platforms like the iRobot Create to research robots like the Stare robot from Stanford University. The ROS development community has taken lots of lessons learned from the many robot software frameworks out there to create the ROS framework that is optimized for distributed computing for mobile manipulation applications. This means that ROS is designed for the complexity and the computational needs of mobile manipulation applications. ROS can be thought of as a foundation on which component technologies and applications are built and tied together. Mobile manipulation systems require a broad set of capabilities that ROS provides. Here are a few of those capabilities that exist today for ROS. Visualization tools for visualizing sensor information and robot state. A navigation stack that can plan and navigate around 3D obstacles. ARM path planning libraries for 3D planning of robot arm motions. Hardware interfaces to many different sensors and robots. A simulation environment. 2D and 3D perception algorithms for processing both camera data and laser data. And a hardware diagnostic system for monitoring sensors and mechanisms. I can't stress this next point enough. ROS is built to make it easier and faster to develop robot software. I want to highlight for you today some of the developer tools that are part of ROS. This simple visual example shows the processes and data streams for the diagnostic system in ROS. An actual full robot system, like the systems for PR2, tend to have about 100 processes. In ROS, these processes can be run easily across many computers, and these data streams between the processes can be anything, including diagnostic information, sensor data, or commands. One key feature of ROS is that any data stream in the system can be accessed anywhere at any time. Many ROS tools take advantage of this feature. One example of this is the ROS logging and playback system. ROS logging lets you log any data streams, from diagnostic data to video data to 3D point clouds, across a distributed system. Our hardware team uses this feature to diagnose hardware issues. Our developers use this feature to test algorithms without needing access to a robot. And members of the ROS community use this feature to share data sets. This is a ROS tool for playing back those log files. In this demo, we have a log file showing in a timeline at the top of the screen. You can see there are many video and data streams in this log file. On the right is a time plot of 2 data streams. Here, you can see the developer select a video stream to view, zoom in and out on the time clock, scrub the timeline in real time and see robot data and camera data, zoom in and out of the timeline, and play back the log file from the desired location. In addition to logging and playback tools, ROS also has tools to make it easy for developers to visualize robot data, sensor data, and see processed data in real-time 3D virtual environment. In this demo, we are watching the robot open a door and go through it. On the screen on the left, you are seeing live visualization of the processed 3D point clouds coming from the robot laser scanners, live with the rendering of the current robot model. There are a lot of other things that you can easily visualize in this tool. For a demo on a live robot head, please come to our booth on the IREX floor. The final developer tool I want to feature is the ROS simulator. To illustrate how powerful the simulator is, I need to tell you a story. 6 months ago, we completed a milestone to open 10 doors in a row automatically and navigate 40 kilometers autonomously in our building, error-free. Ever since, we have been able to maintain this robustness, even while pieces of the underlying system have been in active development, by running automated tests of the door opening and navigation software in simulation. In addition to using the simulator to test code, the simulator has enabled software development when no hardware is available. We are even seeing people in the ROS community who do not yet have a PR2 writing PR2 software. Here is a sample of PR2 navigating offices in the simulator. This simulation is running the ROS navigation stack. On the left, you can see a visualization of the simulated laser data, and on the right, you can see the environment through one of PR2's cameras. The logging and playback system, the visualization tools, and the simulator are just a few of the developer tools in ROS.